Buenos días, good morning. We begin the first session of the day with Ignacio Loizaga. Ignacio is the Chief Marketing and Technology Officer at TELDAT. He's a Master in Telecom Engineer by the Polytechnical University of Madrid and a House Executive Master in Business Administration and IES University of Navarra. After working at Capgemini and Telefónica, he joined TELDAT, where he has worked in different roles in R&D, marketing, and sales. For the last 5 years, he headed TELDAT's Silicon Valley office, and now is the leading TELDAT's transformation for the hardware to a software-driven company, based on network virtualization and software as a service business models. Ignacio, have the floor.
Thank you very much. Thank you very much for the opportunity you're giving me today to speak about a topic that I really enjoy, network virtualization. And I've been asked to be fast and stick to my schedule. So it will be barely 25 minutes in which I will try to introduce the topic of network virtualization and explain how it has transformed and is transforming today 3 environments for telecommunications: the data center, the carrier network, corporate networks, and then there will be 5 minutes, I believe I'm allowed, to speak about my own company and what we do in that space. So first thing, I tried old school. If I were a newcomer to the topic, what would I do? I would search online, what is network virtualization? I looked in, of course, an online dictionary. What is virtualize? It's to create a virtual version of a computing resource. So it's cumbersome. The old-fashioned dictionaries have this tendency to define and use the definition in the explanation. So I had to look for virtual. Virtual is non-physically existing, but made by software to appear to do so. So we're talking about a network that doesn't physically exist, but appears to exist by software. But I am an engineer, and I'm not going to be fooled easily. I know that networks have fiber optics, they have modems, they have transceivers. Those things cannot be virtualized by software completely. So I went on with my search, and I asked my virtual assistant in my phone. Since he's virtual, he should know what a virtual network is better. And, and the definition is a little bit more confusing. So apparently, it's an array of resources, hardware, oh, good, there's hardware, and software that are made to look as an administrative entity, like a virtual unity. Okay, it's still a little bit confusing. So I got lazy and I said, well, this doesn't seem to be that easy. Why should I even care about network virtualization? By the way, there's a synonym to network virtualization, which is software defined and has to do with the previous definition. Software makes a network look virtual. And I like this diagram. Us engineers love polar coordinates. Here the radius is the timeline, 2006 to 2019 and on. And the polar coordinate, the angle, is the business impact. So Atos, which is a consultancy firm, worldwide known, says that SD, software-defined X, software-defined networks, and we'll be explaining what the X stands out for. In 2018, which is in 4 months, we would have early adopters, and it's a technology that is going to have high business impact. So the response to my question, why should I care? There seems to be a lot of money behind this. There seems to be a lot of transformational power. Of course, not anywhere close to what everyone is expecting about artificial intelligence. This talk would be a lot more fun if we were talking about singularity and when machines will be smarter than humans and what will happen with post-humankind. But we got what we got, and software-defined networking seems to be a trendy topic on its own. How did all of this started, because sometimes to understand the trend in the industry, it's important to know the origins. It didn't start with network virtualization. It started with computer virtualization. And computer virtualization came from a very specific need. Data centers were slow, and Amazon, Google, and all the big cloud vendors could not have slow data centers. Why were they slow? Because servers used to be machines that had CPU, memory, compute, storage, network interface cards, an operating system, and an application running on that operating system. One single operating system. You could have a Unix machine, a Linux machine, a Windows machine, but they had to be physically different machines. And that had limitations also because you had to dimension those servers to the worst case of your application. So imagine your Amazon, you had to dimension all your servers to the worst day of traffic in Christmas when everyone is buying in your marketplace. The rest of the time, those servers could not be used for any other application. So someone came with an idea that is, why don't we build a layer of software on top of that, a new kind of operating system, which is called in the market hypervisor, that simulates on top of it different virtual machines. Each application will have a perception that under its needs, it has an operating system that supports the compute, memory, and network interface cards that it needs, but it will really be a virtual appearance, and you can have several virtual machines running on a single server. This completely transformed the way that cloud vendors offer their services. You could turn on and turn off virtual machines as needed. You could have different operating systems on the same server, Linux, Windows, running on at the same time. All in all, and I use the Amazon example again, you could even sell the spare capacity that you had. So if you had to have a huge number of servers for the Christmas season for sales, and you were not using that over the rest of the year, you could sell that capacity to other customers, and that's how the concept of public cloud was born. So all in all, data center communications were transformed by these concepts, and that generated a huge market. I'm going to just mention a curious example. VMware was founded by 5 initial engineers. These 2 guys are married, a couple, and the important, to me, interesting fact is that they could work together and they didn't divorce and they became millionaires. The company they founded in '97 today has a market capitalization of 38 billion, American billions, 38,000 million dollars. So a lot of money, not to speak about all the money that Google, Cloud Services, Amazon Web, or Azure, or Microsoft are making on this technology. So data center was completely transformed. And now you might be asking yourself, well, you're telling us a lot about compute and storage, about the data center, but you haven't talked yet about network. What happened with the network? The network began to be a bottleneck in the data center operations. Imagine that now you have several virtual machines, which are the small white boxes up on top, and running on that hypervisor. Those machines are created and disappear. They need IP addresses. They need dynamically to be accessible with the networking resources. But below that, you have physical switches that are not that flexible. Those switches have good old command line interface. So the IT guys were creating applications, destroying, spinning, that's the word, the trendy word, spinning virtual machines, turning them off rapidly. And the guys that managed the underlying switching fabric could not proceed at the same speed that was required. So someone had a great idea. Inside each of those servers and integrated into the hypervisor, into that virtual machine operating system, let's create a virtual switch. Let's write a switch that can help with the communication of the different virtual machines inside the server and between servers. And that switch is so much more flexible. So they created an overlay of communications. The underlying switches didn't have to change. They didn't even have to bother the guys that were administrating the physical switches, but all these virtual switches were now controlled by orchestrators, by other software, and everything could run smoothly and fast. This idea also created a bunch of billionaires. Actually, one of them is Martin Casado. He's a Spanish-born guy from Águilas, Murcia. And well, with Chris McCune, which is one of the Stanford professor in electrical engineering, created a company in the early 2000s that was acquired by VMware, the previous company I mentioned, by 1.3 billion in 2013. The virtual networking division of VMware last year sold $1,000 million in virtual networking technology. Okay, so we got it. It all started in the data center. It was driven by the need of quick deployment of compute and storage and elasticity in the services of the big data centers. There are other areas where network virtualization has been transformative. When we're talking about communications, carriers suddenly realized, we are communications. What's going on? The data center has changed, and now the expertise and the leading edge is not in the carrier. It's actually in the private business, in Google, Amazon, in VMware. They built their own model because they had to compete with over-the-top services. Otherwise, they would be transformed in just a commodity, a utility, like electricity, water, bandwidth. They didn't want to become that. They wanted to be agile and provide new services. So basically, they borrowed the virtualization scheme that I just explained with virtual compute, virtual storage, and virtual network. And they said, everything that we do, all the good old networking functions, IMS for voice services, the Evolved Packet Core, switches, routers, you name it, SBCs, everything will be virtual network functions. Those applications, those are really carrier applications, will be running on a virtualized infrastructure. And then again, this is tricky because there's a big difference between the data center and the carrier network. A carrier network is distributed. A data center is one single location, infinite bandwidth, no latency. But the speed of light is stubborn. If you want to travel a distance, there's going to be a time. And carriers have distributed networks. So they understood that their model had to also be distributed. There were certain VNFs, certain applications that could be run in their own data centers, but others had to get closer to the edge. Routers, you need routers everywhere. So if you want to virtualize routers and switches, you have to virtualize them at the central office. And there's another effect beyond that. It's Internet of Things is creating what is called in the industry as data gravity. You have to bring the compute and the storage resources close to where the data is. It doesn't make sense if I have a smart vehicle that vehicle is sending wealth of information, video information, all kinds of telemetry information to a place in Google somewhere in that continent. But you need that processing to be as close as possible because the latency has to be extremely fast. So it's funny because there's it's a pulsing story. There's mainstream, there's PC, there's in the industry some years where the trend is to concentrate, sometimes it's to distribute the intelligence. Now there's a trend. After that, we were convinced that everything had to run in big data centers in the cloud, that the cloud has to be distributed and become like a fog. So in the carrier environment, all this translated to central offices. The good old central office was transformed and is being transformed into a little data center. It's the COIT initiative, central office re-architected as a data center. And basically, the only hardware that remains there that is not virtualized is the actual modems, the fibers, the coax cables. The rest is an underlying leaf spine switch infrastructure and virtualized networking features. They went even beyond. There were certain features that had to actually be executed at the customer premises because the response time or the availability needs required so. So that leads to the concept of a virtual CPE, a kind of a micro data center that has a hypervisor and several virtual machines. It's like a server that emulates the same architecture that we see here. You would expect now a third part of this slide to show you some billionaires. Well, the bad news is no billionaires here, and I'll explain why. AT&T, who is a thought leader worldwide for this trend, claims to have 35% of its network virtualized at this point. This area, which is called MANO, Management and Orchestration, is really the core of the added value. The rest was already somehow invented. VNFs would be supplied by vendors, but that huge part of software is critical, and carriers don't want to rely on vendors because it will create a huge dependency. So what they have done is they have created OwnUp, which is a consortium that includes China Mobile, China Telecom, AT&T, Orange, and I just read Verizon joined last year. So 55% of the subscribers worldwide are served by those carriers. And what they're doing is that they're joining forces and donating engineers that are developing a single huge code that will be a denominator, a common denominator. They said, we're all going to need this piece, so let's work together and try to build that piece with our own resources. And that kind of explains that there's not much private initiative in this field other than providing VNFs, let's say smart added value functions at the top of the stack. Okay, so data center, carrier network. What about the corporation? Corporations have a different view on this. Traditional communications in a corporation are the lower part of this diagram. Branch offices, where you have your employees, need to access resources in a private data center. That has been the paradigm for many years. Things started to change. Private data center, of course, started to be virtualized. If you are a corporation, the trendy thing is to say, oh, my data center is completely virtualized, 70% virtualized, 80% virtualized. If you're not virtualized, you're a loser. But then we talked about it. Public data centers offer a different business model. Instead of owning your own data center, you could lease capacity in a data center that someone else operated. That has higher economies of scales because they're serving many customers at the same time. That's the famous Amazon Web Services, Google, Compute Engine, Azure services. Okay, so now as an enterprise, I have to decide which applications make sense that I run in my private data center, confidentiality, privacy, regulation, and which I can offload to a public data center. But even beyond, why should I even have my own mail servers if Microsoft can do it for me? So there's also the model of SaaS consumption of services, where my email will just be hosted in the cloud. And we are becoming used more and more to use cloud-based services. So the data center becomes a distributed data center, a kind of a cloud of clouds where I use resources as I need them. But let's not forget, most of the workers of that company are going to really be remotely located. So they need to have a big highway through which they can access all those services easily. And that highway cannot be a hub and spoke architecture where all the traffic goes to my private data center and then goes to the internet. That wouldn't be efficient because a lot of my traffic is already going to flow directly to the internet. So internet lines become part of the equation, and this leads to a new technology for the WAN that is called SD-WAN. And this kind of explains the SDX I mentioned at the beginning. There's SD everything, SDDC as software-defined data center, SDN, software-defined networking, SD-WAN, software-defined connectivity for the remote sites. What makes this virtual? There doesn't seem, some of these elements will be physical, some of these elements will be logical, but what makes it all software defined is that you can really write code and offer primitives to the IT guys that write their computer programs, so that they perceive that with a call to a specific function, they can trigger a line, have more bandwidth because they need it for a specific application, or shut it down. So networking resources can be consumed in a programmatic manner. That's what makes all this a software-defined solution. So control, provision, understanding of what's going on in the network with visualization is what makes this proposal fully integrated into the SD vision, into the network virtualization vision. Going a little bit deeper, because this is kind of the area where I am an expert in, what we want for the corporations is that they have independent of access, that they can use any line to communicate to all those distributed data centers we were talking about. Of course, corporations always want to save money, so if I can lower my bill with the carrier, even better. I want to migrate my applications to the cloud. I want to know what's going on. I want everything to be provisioned automatically. I don't want to have to deploy a rocket science expert to each branch to install a communications device. And I want to control everything from a console easily. And I was told I could have 5 minutes to speak about my own company and what we do in this space. TELDAT is a Spanish company. We are the leaders in Europe for network virtualization. We have more than 500,000 devices, hardware and software, deployed in about 800 critical networks, including very large customers in Spain, Santander Bank, BBVA, many government institutions, but also if there's someone from Germany here, German supermarkets, Lidl, Rewe. We have Boston, the transportation system. So many customers worldwide using technology developed in Spain. What we do is mainly applies to different areas: branch office networking, corporations consume our technology. Mobile access, as I mentioned, high-speed trains, and I tell you it's tricky to maintain a session going on when you're moving at 300 kilometers an hour in a high-speed train, and we are doing that in the Spanish railway system and in Saudi Arabia. Smart grids and metering, there's a lot going on also with IoT and bringing compute close to and making cities and making grid smart. Now with the smart car and solar panels and the distributed generation, there's a big transformation going on there. Intelligent voice solutions, voice and multimedia communication between humans is still very tricky because it's real time. It cannot afford to have big latency. And migration to IP, which is another trend in the industry, because good old switch telephone networks are being turned off and everything is becoming packet switched, and there's a big opportunity there. So again, Spanish company, 60% sales, international, state-of-the-art technology. And what's our vision regarding network virtualization? We want to be a bridge between the three worlds: the carrier world with their NFV and VNF and those distributed functions in the network, the software-defined WAN, the corporate needs that, of a better communication to the distributed cloud, and the SDN, which is a software-defined network in the data center. So we are not the ones saying that we are a relevant actor. It's Gartner that in their reports says that, well, we are one of the leading actors in this space globally. And what we do is a combination of hardware and software remote devices that basically include switches, routers, virtual switches, virtual routers, access points, phones, that both virtual and physical phones that communicate to an overlay of software that virtualizes and makes it all software controllable. So software-defined Wi-Fi, software-defined WAN, software-defined LAN, and there's a northbound, and that's the word in the industry, interface that allows IT departments to consume, both in the carrier and the corporation, those services easily. And I have I don't know if I'm in time. There's another slide for trends, but I don't know if it makes sense. Maybe if he doesn't complain, I'll tell you what's coming. So virtual machines are already becoming obsolete. That's how fast our industry moves. So everyone was executing Linux. So they say, why do we need to emulate Windows at the same time or emulate Unix? All we're using is Linux. So instead of simulating different operating systems, what we're doing is sharing Linux chunks. That's the container technology. And everything now is moving quickly to a containerized approach. I mentioned cloud of clouds. Just 2 days ago in Barcelona, I saw a demo from VMware. They were running software in a data center in Hamburg, and with a click, they moved all those virtual machines applications and started running them in Paris at the power of a click. That's amazing. One was a private data center, the other one was Amazon Web Services. It's incredible. All these cloud resources are going to be flexibly consumed. There's going to be a brokerage. We're going to be able to use them on demand. Intent-based networking. So we want the network to be programmable. Okay. Now we're going to let artificial intelligence and machines understand the intent for which we want to use the network, and therefore have themselves configure the network and adapt to the needs that I have. Edge computing, distributing all the compute to the periphery of the network. And I'm not going to step into 5G because there's Ericsson that's going to talk about that. But 5G is going to be completely defined by virtual networking. And that's it. Thank you.